Okay, in this video we're going to look really quickly at position versus time graphs and all of the things that go along with that. So, position versus time. The first way that we want to look at this is talking about a number line. And something that I'm going to call a dot diagram. So with this number line and dot diagram, what's really important about this is that we place a dot every second, or every 2 seconds, or every 10 seconds, but we're laying down a dot every second. So imagine you're walking down the road with a whole bunch of sugar packets. Don't know why you would do that. And you're going to drop a sugar packet every 2 seconds. You've got a timer on your phone that's going to beep. At 2 seconds, you're going to drop that sugar packet. So it's just a number line. And so let's say we're going to go 10 meters. 20 meters, 30 meters, 40 meters. And as you walk, you're going to drop a sugar packet every so often. And so after 1 second you dropped a sugar packet, well, we said 2 seconds, right? So 2 seconds you dropped a sugar packet, 4 seconds, 5 seconds, 6 seconds, 7 seconds, 8 seconds. So that's you dropping sugar. Well, I did that backwards again, didn't I? 4 seconds, 6 seconds, 8 seconds, 10 seconds, 12 seconds. And so the intervals here where you started, if we just draw an arrow for every little interval, those arrows are telling you about your motion. So the things that we notice here, the arrows are the same size. That means we moved the same distance per interval. And we're going to talk about what that means in a second. But that's kind of what the arrows are indicating. And then the direction of the arrow is your direction of movement. Those are the things that the arrows tell us. Now, this little description, distance per interval, I want to get a little bit more exact as we're talking about it. So as we're looking at distance per interval, I want to take this, I want to define it better. And so right now what we're going to do is call that thing speed, and we're going to define that as distance traveled over our time. And what that really gives us is an indication of the distance traveled per interval. So that speed is distance over time, distance traveled per interval. What that's telling me is that the arrow, the size of the arrow, is equal to the size of my speed. The bigger that arrow is, the faster I go. That's looking at dot diagrams. Now, we took these dot diagrams and we stretched them out to create a distance versus time graph, or position versus time graph. So for this distance versus time graph, we put our position up here and our time over there. And if we had our little positions, imagine if we drew our dot diagram right here and we stretched them out, right? So if we move that over, and we move that over, move that over, we move that over. And if we wanted to connect those arrowheads, what we would get is a good indication of how we moved as time went on. Okay, this is a distance versus time graph. Now, for any graph, if you remember, slope is the rise over the run, or your change in your y values divided by your change in your x values. Well, in this graph, your change in your y values is change in position. And your change in your and your change in your x values is your change in time. So if we look at the slope here, the slope for this graph, this particular graph, it's the rise, change in position, over the change in time, which is speed. So the slope of this position versus time graph is the speed that our object had. So if we're going to calculate speed for a given interval, we're going to use speed is change in position over change in time. And we can use our graph to get change in position over change in time too. Now, if we want to take this graph thing just one step further, for a straight line graph, we have y equals mx plus b. Y are my y values, x are my x values, m is the slope, and b is the intercept. But if we put that in terms of the things that we talked about here, our y values are change in position, right? So the y value is now our change in position. We're calling position x. It might get a little confusing. That's okay. Our x values here are change in time. So that is going to be time. Our slope values, the m, slope is the same thing as speed. So we have velocity. And then our y-intercept, that guy's a little tricky. The y-intercept is just kind of where we start along here, which is our initial x position. So we say x initial. So our final x position is velocity times time plus the initial x position. So here we've got the two equations that we're going to use. That's how position changes if I have initial position and I want final position. And this would be how to find the speed, delta x over delta time. You're going to use these two things today.